In this video, we want to derive the formula that states the integral of du over u squared minus a squared is equal to 1 over 2a, natural log of the absolute value of u minus a over u plus a. U could be a function of x. Here, a will be a constant, so you have a difference of squares. This could be x squared minus 4, or some other expression that's a function of x. But it states if you can write it in this format, you can easily get the answer this way. Now you can also recognize this as a rational function. So integrate the partial fractions. Decomposition is also going to work on that. And because you don't have any repeated factors, you have 8u minus a times u plus a. The setup, finding the constants is fairly easy. But we're going to derive this particular formula. Instead of using partial fractions, I'm going to set it up this way. I've done this before. I've done it before in other videos. Partial fractions is not bad here. Like I said, you would just have it here. You'd have a constant a over u minus a plus a constant b over u plus a, and go ahead and find the constants any way you want using comparing coefficients or setting up a system of equations. And it'll work. It doesn't take that long to do it. Now in my case, we're starting with this here, and all I'm going to do is rewrite it. I'm going to rewrite it this way. So this will be u minus a times u plus a. Then I have a du here. And remember, this is a 1 then. 1 times du is 1. So I'm going to set it up this way. I'm going to say this is going to be a 2a. Remember, this is a 1. So I put 2a there. And that's only legal if I multiply by 1 over 2a. This is just a constant, so just multiply through the integral, and the 2a's cancel, I get a 1. So that's okay there. Then I'm going to put another equals over here then. The 1 over 2a is still out in front. And then again, I'm going to rewrite the numerator as u plus a and minus u plus a. And this is du. Still have the denominator the same, u minus a and u plus a. Notice we still have the same thing. U minus a, that cancels to 0. A and a is 2a, and then times 1 over 2a gives me the 1. So I haven't changed anything, just rewritten. And then this is equal to 1 over 2a. And then I'm going to break it up this way. Still got the integral here. And it's 1 plus a. I'm going to write it as u plus a over this denominator. The u plus a and the u plus a will cancel, give me a 1. And in the denominator, I still have the u minus a. Then I'm going to write it this way then. It'll be a minus u minus a. So first I did u plus a over the denominator, and the u plus a cancel, leaving me a u minus a in the denominator. U plus a in the numerator canceled. And then in the next one, took this part right here, factored out minus 1, and that left me with u minus a in the denominator and a u plus a. And notice u minus a and u minus a canceled. That left me with 1 over u plus a. Okay, so again, it was u plus a over the denominator, and the u plus a canceled out, leaving me with 1 over u minus a. And then it was factored out the minus there. I had a u minus a in the numerator, u minus a, and u plus a in the denominator, and the u minus a and the u minus a canceled out. So I get 1. Let me just rewrite it this. What's left here? So this canceled out here. This canceled out here. Still got the u plus a here. So u plus a there, and then a 1 here. And this is, again, I could break it up into 2 integrals, but I just do it this way. 1 integral, and then 2 terms to integrate. So what do we have here then? Still got the 1 over 2a in front, and then we just have du over u minus a, du over u plus a. Because the derivative of u minus a and u plus a is 1, I can just say that's going to be the integral of the natural log of absolute u minus a. Got the minus. Same thing in this one. du over u plus a integral is 1 over, or ln, over absolute u plus a. And then it's plus the constant of integration. So this is the integration right here. 1 over 2a multiplied by ln of absolute u minus a minus ln of u plus absolute u plus a plus the constant of integration. Then we'll move up here. And then to get it in the form like it was given, this is just going to be then 1 over 2a. And all I'm going to do now is use properties of logarithms. When you have a difference of logs, you can write it as a log of a fraction. One absolute value is all we need here. So again, difference of logs can be written as a log of one fraction. So this would be u minus a here. In the denominator, u plus a, plus your constant of integration. And that's the confirmation right there. So again, this is telling us then that anytime you have an integral in this form, it's written in this format. Now this could be an x, no big deal there. Or could be a function of x. Anyway, if you can write it in this form, du, integral of du over u squared minus a squared, difference of squares, then the value of that integral is given by 1 over 2 times whatever the a is a squared. So whatever the a is, ln of u minus whatever the a is, over u plus, again, the value of a. So this confirms or shows how to derive that particular formula. Thanks for watching. We'll see you next time.